View adds a number of capabilities beyond just plain generic virtual desktop infrastructure. View has its own remote display protocol called PC over IP. Essentially what PC over IP is a more efficient rendering engine for rendering your desktop. And so what PC over IP does is it tests the speed of the network, it tests the latency, the packet loss of the network, and it adapts to changes in speed, changes in latency. So one of the ways it adapts, for example, is in PC over IP, when it updates the screen, if you have lots of graphics on the screen, it will update the screen by sending a low resolution image for each graphic. And then if you loiter on the screen, it will refresh the low resolution with medium and then higher resolution images. So what happens is, if you loiter on the screen looks great. If you click on something and then you start to look at it, then you go, well, that's not right, and you click away, you don't have to wait for the high resolution image to show up before you can actually move on. It has USB redirect capability, it has printer redirect capability, it has full multimedia support for audio and video streaming that you can centrally control. So you can actually set the default quality for flash video. So you can say, by default, all flash video should be medium quality, because you know how quite often flash will have low, medium, and high quality settings? It'll automatically set whatever you want. And then you can also set the frame rates. You can say, well, you know what? I don't really want people watching flash videos while they're working, so I'm going to set the frame rate to poor. Maybe 2 or 3 frames a second. You can do those sorts of things. View includes a connection broker. A connection broker is a gateway into your View environment. So basically what you do is you take View client, you point it at the connection broker, the connection broker authenticates you, and then it goes, okay, based on who you authenticate as, you can see these VMs, which one do you want? So you can only talk to your VM if the connection broker thinks you have permission to talk to your VM. You can't just go and connect to anything you want. And I can replicate the connection broker. It's called Replica Server, and the idea there is, I don't want connection broker to be a single point of failure. I want connection broker to be replicated so that if I can't get to connection broker, it's busy or down, I can go to some other replica server, authenticate that, and get to my VM that way. Okay? I can have pools. Pools are groups of VMs that are managed with the same policies, properties, and so on. So they share provisioning rules. So provisioning rules would say, how many VMs do I provision in advance? They would say whether my VMs are dedicated or floating, VM assignments. They would say things like, is it a standard VM or is it a link clone VM? That sort of thing. Okay? Now, one of the things I can do is I can even treat a VM like a library book. I can check it out, take it with me, use it locally, and when I come back from my business trip, I can check it back in, and it synchronizes all the changes. I can even set policies on checkout and check-in. I can say, you know what? You can check it out, and you can run it for so many days, maybe 7 days. After 7 days, if you don't sync it back in, the VM stale dates, and you can't use it anymore. I can set security policies. I can say, you know what? When I check out a VM, the virtual disk is encrypted. So if somebody were to steal your notebook while you're on a business trip, the VM's useless to them, because without the decrypt key, it's just a bunch of gibberish. Okay? And I can also do application virtualization with a product called FinApp. Now, View looks like this. I have my vSphere infrastructure. So I have my ESXi hosts. I have vCenter server here. I have local desktops, notebooks, desktops, thin clients, zero clients, tablets. But I don't use them for local desktop computing. What I do is I run View. The foundation for View is Connection Server and View Manager. View Manager allows me to create and configure View, and Connection Server is my connection broker. With View Manager, I can create one or more pools of desktop VMs and run them in my data center. And then what would happen is, using View Client, I would connect to Connection Broker, and Connection Broker would say, well, Larry, since it's you, I'm going to connect you to your dedicated VM right here. And from now on, all of my interaction with that VM would be brokered through Connection Server. If Connection Server were to fail, I would lose my connection to a VM. But I can pair up Replica Server with Connection Server. And the neat thing about that is, if Connection Server were to be busy or worse, I could simply connect to Replica Server, authenticate to that, and it would broker my connection through to the backend VM. Okay, so I can do that. Now, what else? All of my authentication is done through AD, so I have to have an Active Directory service somewhere. I can use Transfer Server to check out VMs and take them with me, say, on a business trip, if my pool policies allow me to do that. And I can also use Security Server. Security Server is a special instance of Connection Broker. And what Security Server does is it allows me to connect through an untrusted network and then redirects me over to a trusted connection broker. So that way I could be out at an internet cafe somewhere in the world, hotel, whatever. I could take out my notebook, I could launch View Client, connect to a Security Server. Security Server would say, give me your credentials. It would first of all actually open up an encrypted connection. Give me your credentials. It would then take my credentials, hand them to the paired connection, a Replica Server, authenticate me, and then what it would do is give me access to my desktop from wherever in the world I happen to be. And I would work like I was working locally. So this is how the pieces fit together. Now, let's move on. I get many benefits from doing this. I move my application and data off of a cheap consumer-oriented piece of hardware, in other words, most desktops, into the data center, where I have a team of professionals who will manage, administer, backup, recover, secure, resource balance, and so on. I can then set up policies about authorization and authentication. I can centralize the patching and administration of my desktops, the updates for security and so on, the deployment of applications, all that sort of thing. I can enforce encryption when accessing my desktop. And I can use multi-factor authentication if I want to ensure that whoever's accessing my desktop is who they say they are. I get improved availability. Desktop PCs are not the most reliable beasts on the planet. You know, I have cheap consumer hard disks, I have cheap consumer, fans and things like that in them. They fail. Well, if I take my desktop OS and I turn it into a virtual machine and I run it on my vSphere environment, then I get perhaps the benefits of a load balance cluster combined with the benefits of a failure recovery cluster. So my resource needs are always met, and if, God forbid, the physical PC server running my VM were to die, HA would step in and say, well, no problem, go to this other host, he'll boot you up and run you. So if the PC server dies, I only experience a few minutes of downtime, and then I'm right back to where I was. Okay? I can protect my VMs with snapshots, so that means I can do patching and updating with snapshots, and then decide later on if I want to revert or commit my updates. I can use snapshots as a backup and recovery mechanism, since most modern VM backup tools now are snapshot-based. It means that I can do nightly backups of the entire VM, and that I could recover the VM if, God forbid, something went wrong, or if I did. You know how sometimes users just do something and it just completely destroys their machine? Well, I could always just go back to last night's backup and just restore the VM as it existed last night and just say, here you go, your VM's back. Whatever you did, don't do it again. That sort of thing. Or I could spin up a copy of their VM in my DR site if, God forbid, my primary data center went down. I can manage this centrally through View Manager. It's a very easy-to-use web-based administration portal. I can use View Manager to create pools, and those pools can be anchored off of templates. In other words, whenever you make a new VM, just use this template and customize it with this GuestOS customization specification. It's very scalable, it's very easy to use, it's wizard-driven. Again, I get a better remote display protocol. The display protocol, PC over IP, was intended to be as close to local desktop responsiveness as possible. And again, it adjusts to and compensates for varying speeds and reliability for the wide area network. So it's constantly adapting. It's more efficient. With View Composer, I can make something called link clone VMs. A link clone VM is a group of VMs that all anchor to the same virtual disk image. So in other words, when I boot up a new VM, the storage consumed for the new VM is just enough to hold the changes between the base image and whatever the user has changed in their VM. Okay? So the local virtual disk only accumulates the differences. This significantly saves on disk space. So for example, if I had a Windows 7 VM whose base image was 100 gigs and I had 50 users, without link clones, I would have to deploy 50 times 100 gigs, which is 5 terabytes of storage, to hold 50 copies of essentially an identical virtual disk image. With link clones, I would have one 100 gigabyte base image, and I would only have a few tens of megabytes to gigabytes of accumulated changes per user. So I might be able to hold those 50 users quite nicely in 1 terabyte or maybe 2 terabytes of storage. So that would save me SAN storage costs. Now, here's the cool thing. Link clones are awesome. What makes them awesome is this, is what I can do with link clone is I can take the base image, boot it up, upgrade the software, shut it down, make a new snapshot, and then in View Composer, I can do something called a recompose. And a recompose says, hey, all you VMs, the next time you reboot off the new snapshot, not the old one, and the new snapshot has the new version of the software. So all people need to do to get their software updated, and that could be applications, it could be tools and utilities, it could be updates to the operating system, is reboot, and everybody gets the update. I don't have to, for example, upgrade from Office 2010 to Office 2013 by installing it on 50 different VMs. I install it on the base image, everybody reboots after a recompose, and hey, look, it's Office 2013. Problem solved. It's so much easier.